Welcome to Cloud on Air live webinars from Google Cloud. We are hosting webinars every Tuesday. My name is Amy Krishnamohan, and I'm here with Prashant from MongoDB. And today we'll be talking about building modern app with the MERN stack and Google Cloud Platform. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. So let's get started.
Hey, Amy. Hi, I'm Prashant, and I'm a solution architect at MongoDB. So let's just get rolling. So today we'll talk about mean stack and MERN stack and how we can build a simple to-do app on MERN stack and deploy it on GCP. So a little bit of history. Valery Karpov, he was a MongoDB developer, and he, as a part of hackathon, tried to show that how MongoDB is the easiest database to work with, and he chose mean stack. He chose Express, Angular, Node.js, and that's how it came to mean. And what he saw is not only MongoDB is easy to work with, also having JavaScript full stack made development pretty easy, and they had to do less context switch. And MongoDB was a natural choice for saving JavaScript objects without any transformation, without having an ORM layer. So this is how application in mean stack look like. We have a front end which is built on using Angular, and then a backend REST APIs using Node and Express, and MongoDB Node driver, and which talks to the MongoDB database. So after that blog post came, and the mean stack has evolved. MongoDB went from 2.6 to 4.0. Similarly, Express, Angular, Node, they all went from, Node went from 0.11 version to 8.11 today. A lot of feature update. It's a great stack to work with, gives developers a lot of productivity. But the web has been changing. There is a shift in web technologies. On NPM, 60% of NPM users say that they are using React today. So React has been rising in popularity, and there are some good reasons for that. So a quick discussion of like how AngularJS compares to React. Again, it's not an apples to apple comparison. They are different, and they are both great in their own accord. But Angular is a framework. It's big. It's very opinionated. It has a standard way of doing things. It kind of builds on everything in it. You can use conditional loop, ng for, nj if. It picks its own syntax. It's a little bit constrained. Versus React is a small library. You can bring it in your existing application. You can upgrade application in a piecemeal way instead of doing a big bang. It is primarily responsible for the view, and it is more focused towards using JavaScript. So it is very, very natural to JavaScript developers to build on. And if you know JavaScript, and we'll talk about JavaScript extension, it makes the developer productivity pretty high and easy to learn. So provides you freedom. You can bring in other libraries to have more features in React, and we'll talk about that in this application. So moving on, again, this shows that in past 2 years, React has really risen. Okay, so and hence we come to the MERN stack, which is Mongo, Express, React instead of Angular, and Node. The application architecture stays pretty similar. We have front end built in React. We have a backend which is built with MongoDB driver, Node.js, Express APIs, and the MongoDB. So a quick introduction to our example application we'll be using. It's a simple to-do app, and it lets you add a task. It lets you see the task. It lets you update the task with like completed or delete, edits, and the front end is built in React. So we'll look at this application in detail. Again, you can add a task. So now what I'll do is I will go over the MERN stack, starting from M, which is MongoDB, and why MongoDB. So MongoDB, in very shortly, like it's best way to work with data. Why? Because MongoDB is very flexible. Its document-oriented nature lets you save your objects directly to the JSON object, directly to the database without doing any kind of transformation. You don't have the ORM layer, which makes it really flexible. If you add new fields or something, you don't have to really change your application logic. it's very fast because there are no transformations. So with those reasons, and also lets you support different types of data there. Also, MongoDB lets you intelligent put data where you need it. So for example, you can build a globally distributed sharded cluster, and if your users are distributed, you can have read replicas, and you can do workload isolations where users can do their analytics workload. So you can choose where you want to put your data. And finally, MongoDB provides you freedom to run anywhere. You can run it from mainframes to on-prem to clouds and all the public cloud providers today. So all of this makes MongoDB an intelligent operational data platform. So we talked about this. MongoDB is easy, it's flexible, it's fast, and versatile. So we'll look at that in detail. MongoDB provides drivers for a lot of languages. In this case, we are using Java, Node, and Node.js, and it provides a idiomatic driver, which basically is very intuitive, very easy to use with the Node language. And you can do npm install MongoDB to just get the driver. So we talked about how the JavaScript framework changed, and let's look at MongoDB evaluation. The original blog post was 2.6, and this slide shows from 3.0 to 4.0. We have added a lot of great features. Multi-document ACID transactions came in 4.0. We have changed the stream to quickly react to the change which is happening on the data layer. So these all features, I'm not going to go through each of the feature here, but it shows how much work MongoDB team has put in and made it really developer friendly and increases developer productivity. So with this, today with GCP, we'll be using MongoDB Atlas, which is a global multi-cloud database service. What this means is it's a database as a service. It lets developers self-service the database, MongoDB, whether it's one replica set or you want to do a globally distributed cluster, you can do it with few clicks. And it's elastic. It lets you scale it up and down using APIs or from the UI. Lot of security features, enterprise-ready features, network isolation, you get encryption, you get guaranteed reliability with different SLAs. So a lot of enterprise features. Atlas UI brings in comprehensive monitoring. You get metrics on 100 plus KPIs in MongoDB. It helps you manage backups, and also with MongoDB Stitch, you can do serverless integration. You can define access rules. You can integrate with different cloud services and launch functions. So all of this in a cloud agnostic way. It runs on AWS, GCP, Azure, and every cloud has their own strengths. So we'll see how MongoDB works with Atlas works on GCP. And so I'll switch on to a quick demo. I'll show you how to deploy a flea cluster of MongoDB Atlas on GCP. So if you go to cloud.mongodb.com, you can quickly sign in and build a free cluster. It's a 512 MB of space, doesn't require a credit card. So you can just go in and get into Atlas, and then you will get to the screen, build a cluster, and choose Google Cloud Platform. And where you see this blue oval thing highlighted, so we have 3 free tiers available in Iowa, Belgium, and Singapore. So in this case, I'll choose Iowa. And then this is free. 512 MB of storage. Looks small, but actually it's pretty big. For example, if you compare Shakespeare's whole work fits into 5.6 MB of data without formatting, of course. But this is a really great way for you to get started and build your cluster, and you can always upgrade to a higher tier when you need to. You can give a cluster name, click on create cluster. It takes about 4 to 5 minutes to create a cluster for you, and you can get started coding. So going forward, we saw that, and so the next part of the MERN stack is Express, and with Express comes Node. So Node.js really revolutionized how we do server-side applications with using JavaScript. It uses V8 engine, really gives very good performance. It has features, HTTP built in. It's asynchronous in nature, provides you callback functions, promises, observables, and also you can just do npm package manager. Everybody should be familiar with that today. You can very easily install MongoDB driver on that. And what Express does, it builds on top of Node, and it's a library which is basically provides you a web framework. It lets you do routing in your application. It provides a middleware for view engine views. So in our case today, we will be looking at basically using Express to expose the routes we have, and also provide the APIs for create, update, delete of the to-dos. So let's quickly jump into the code and look at the application here. And so if you see here, we have a server component and we have a client. So the server part is what is built on Express and Node.js today. So if you go here, we have APIs, the source. So we can quickly look at the APIs, the routes, and so the route basically tells when you get an API call, which dash it goes to. So for example, when the ID goes in and the HTTP methods put and delete are mapped to different actions on controller. And then if you go to root, then it can, if you do a get call, it will list all the to-dos, and similarly, if you do a post, it can create one. So let's look at the controller. Here is the update method. A request comes in, and based on the ID, we use MongoDB driver and do update one, and use the ID to basically do the updates. Similarly, delete works on the ID, list, which does a find on the to-dos collection in MongoDB, and then sort it on the due date and converts it into array. So you can see here, connecting to MongoDB is pretty simple. We use the Mongo client from the MongoDB driver, and from the environment variables, we are getting the MongoDB URI, which is connected to Atlas, and then it connects to MongoDB, and the application is listening on a port 8000. So that was a quick view of the server. We'll look at the client part of it next. So then it comes to our view part, which is built on the React, and React is, as Facebook's like GitHub Project says it, it's a JavaScript library to build interactive UIs. React is really great. It is based on a component-based architecture, so it lets you write component and then compose them to make really complex UIs. You can divide the UI into logical, simpler components. You have classes and you have functions. The classes can take props and can maintain a state. And also it uses JSX, which is a JavaScript extension to create HTML-like code. If you look at here in this particular example, return h1 hello and the properties.name h1. So it looks like HTML, but it's actually JSX. And React transpiles it, basically Babel. It uses Babel to transpile it into the React DOM, and then you can do render and ask React DOM to give you what you want to see and use JavaScript. So if you're a really good JavaScript programmer, it basically, as you learn React, you become a better JavaScript programmer as well. So let's again look at the code quickly. So here's the client, and you can see that I'll go to the source, and we can see all the components of our application. So we have a component for adding task, we have the whole task, and we are using Google's Material UI libraries for providing the styling as Material UI. So we have a task, and then we have add task and task focus, listing of all the tasks. All these things are composed as components, which we bring together into the app and provide a complete app for you to use, and we'll look at that. And then we can look at the context, some actions. So what happens when we do update tasks? So an update task sends an API call to our server part, which we showed based on ID, and it does the update, gets a response, get it back onto the UI. So really makes it easy for developers to not context switch when you're using the whole stack. You saw with MongoDB, there was no translation. You take the JSON object, you store it into database, and voila, there is no ORM to take care of or any other middleware. So yeah, we looked at that to-do example, and then the task, which is composed, uses Google's material design and builds up the whole task screen. So let's quickly look at how the to-do application looks like. So it is running today on my local host 3000, and I'm connecting to Atlas cluster. You can see all the tasks you have, to-dos you have, and then sorted by overdue, or if you just want to filter it to due soon, and you want to look at a completed task, you can do that. You can quickly click here and mark it complete since we did it. So this is a simple app which is built on the MERN stack. And one final thing before we look at how we can easily deploy it on GCP is, like, if this is MongoDB Compass, which is MongoDB UI to connect to Atlas clusters and or any other MongoDB installation, and you can connect quickly and see what collections I have, what are the documents as I talked about. These are the JSON documents, and you can quickly see that. You can visualize the schema. You can build complex aggregation pipelines if you have to with Aggregation Pipeline Builder we just launched in MongoDB 3.6 and very enhanced in 4.0. So with that, I like to hand it over. So we have built the app. We have our Docker containers ready. Yes. And I'll hand it off to Amy to show it how it goes on the GCP.
Thanks, Prashant. So we have a great app. Oh, my screen is locked. So let me fix that first. Okay. So now we have a great container that built by MongoDB team, and now we are ready to deploy that into Google Cloud Platform. Obviously, there's a multiple way that you can deploy this. You can just spin up the Google Compute Engine and then really build a stack from the scratch one by one. But I would rather take the easy way using Cloud Build and Container Registry and Kubernetes Engine. And within just 3 steps, you will be able to install and deploy this great app. So before we get started, let me give you a quick overview of the Google Cloud Platform, why people are choosing GCP. A lot of customers are coming to GCP, mainly not just because they want to reduce the cost or increase the reliability or security. They're really coming to GCP to look at more way to innovate. A lot of customers are asking how we can better engage with the customer, or how we can improve the productivity of our employees, or how we can better partner with other business. So it can be anywhere small individual project, or it can be CEO or board level initiative to really rethink their business model. And Google Cloud Platform is really built on these 3 fundamental principles that you can see on the screen. Our focus is really building a great tool so that you can focus on the work that is really impacting to your business. We continue to expand globally. We have 55 zones will be available by the end of 2018 and 17 new regions. Hong Kong is coming very soon this year. And let's talk a little bit more about our global network infrastructure. So Google has been invested $30.4 billion past 5 years to really set up this great infrastructure all over the world. We have over 100 endpoints and 7 subsea cables, which is more than any public providers that are existing right now, to really provide a secure private network to our customer. This network is only available to our customer and Google use, and it handles anywhere between 40% of global internet traffic in any given day. So because it's a private and is only available to our customer, it is less susceptible to any attack and is much more secure. So now we talked about the infrastructure, so let's talk about the container. So Google has been developing and using the container to manage our application over 12 years. And pretty much everything that you know about Google runs in a container, whether it's Gmail or search or MapReduce job or even Google Cloud Platform. And we also run our VM on the container. So you can pretty much imagine. So everything is in container. And let me ask you this question. How many containers do you think we launch every week? Can you guess?
1,000, 10,000?
So we launch 4 billion containers per week, which is a really large amount. Yes. So now that obviously a lot of customers, as well as Google, had this issue about managing the container. So managing one container is fairly easy, but what about 1,000? What about million or billions that we are talking about? So we really need to scale, find a way to scale this management, whether it is taking care of deployment, monitoring, and updates, discovery, scaling up and down, and how do we isolate certain workload to that container, which is a very hard problem. So Google initiated a project called Borg, where it is really abstracting the way that how things are done. So the way it works is we tell the Borg that what we want, and then really figure out how things to be deployed. And that can be, it was used in a lot of service jobs like a web front-end application, as well as the Google flagship database like Bigtable and Spanner. Everything is run on container and they use the Borg. And that really led to a start of the Kubernetes, which is an open source project initiated by Google. And it is a container orchestration tool. But what we really emphasize is that the Kubernetes manages application, not just machines and containers. It is 100% open source, and it is written in Go, which someone prefer to say it is only true language. And then ever since we open sourced the Kubernetes, we actually saw really fast adoption in the industry. We saw about more than 4,000 projects are started based on Kubernetes. We see contributors from individual contributor to big enterprise like Red Hat, Microsoft, VMware. They're all contributing back to Kubernetes ecosystem. And we are gaining, Kubernetes is really gaining a fast popularity. And then we really thought that it's important to open source this technology because the importance of this orchestration stack in the web area. So now we talked about the container and the Google Cloud Platform. Let's get back to our demo and really deploy our MERN stack app to Google Cloud Platform. So first step is to go to GitHub. This GitHub is made available by MongoDB team. As you can see, there's a container for a client and a server. And this is a URL. You can screen capture, or we'll make the resources slide available at the end. So go to GitHub and clone that repository using git clone and build a container, which is a very straightforward step. You can use a Docker build command for the client as well as the server. So once you're done with cloning the repository and building the container, the second step is registering the container registry. So container registry is the place we provide as a Google Cloud Platform to really maintain all the containers that you have into a single place, so that that container can be available to other infrastructure like Kubernetes or other products that we have in the GCP. The way you do it is you can tag the container with a certain name and then push that image using command called docker push. So you can do that for client and server. So let me show you the console. So this is the container registry, and which I already pushed the container, and you can see the client and server container available in our container registry now. So now that we have container all registered in the container registry, let's go to step number 3, the exciting step, to deploy that in GKE. So GKE is a Google Kubernetes engine. It's a fully managed service for Kubernetes. The first step that you need to do is create a cluster. So way you can create a cluster is you can actually go to UI here and Kubernetes engine, select Kubernetes. And you can simply choose to use a UI and then add all the variable setting of the location or zone and how many nodes that you need. Or you can use a command line, which I chose, and then create a cluster. It takes anywhere between 4 to 5 minutes, so I made it in advance. So we can take a look at the cluster that we created. So we look at the kubectl, get nodes, and this will show the number of nodes that is available for this cluster, webinar MERN.
Nice.
Yes. And then we can see how many pods are available here. Get pods. And you can see there's no resource found yet because we haven't done it. So next step is to run a container registry image to a Kubernetes engine. So now that we have this available, so let's deploy those 2 containers. You can do it in the UI. So simply you can select the container registry image, and you can see from the drop down there's a client and server available. So you can simply select and then also add the environment variable about the MongoDB databases. Or you can also use a command line in the Cloud Shell here at the bottom. So let me take a cheat sheet and then copy the command. So this is where you can add a pod for the server. So, and you can see this deployment app server is created. So once the pod is created, you have to expose that services to external world. So you can have a second command line here to expose the server. And you can see the server exposed. And we are doing the same step for the client. So let's create a pod. kubectl run client image, and it's created. And then make the service available here. And client is exposed. So you can see again, we can do kubectl and get pods, and now we'll have our information here. And you can see that status is running and it's trying to assign the static URL. So you can see the cluster information from the UI here, and you can see the workloads that are assigned. You can see the client and the server, and the services are assigned for the client and server. So you can see it takes some time to actually assign the static URL. So you can see the live information from the UI, or you can do kubectl get services -w, and it will show the data in real time. So you will keep continuing to check whether the service is available and the external IP is assigned, and when it's assigned, it will show, it will update you in the real time.
Right. Let's look at the app.
Yeah. So we need to have an endpoint.
Yes.
So it's taking some time. And let me tell you a little bit more about this Cloud Shell. So Cloud Shell is a command line tool that is integrated in the GCP. So you can simply click the small box on the top right corner here, and if you click it, and you'll be able to see the Cloud Shell in the bottom of the screen. And it seems like it is being updated. So let's see. So let's refresh the screen. So now the endpoint is available, and we'll click here. See, this is a tool app. So in the simple 3-step, we were able to deploy this. So let's add a task. So Cloud OnAir, and we are doing demo. And let's save it. And you can say that the task is completed, and we can mark it as complete. So let's go back to MongoDB side and see whether this task is saved in the databases.
Nice. So right now what you're seeing here is MongoDB Atlas, and I'm showing MongoDB cluster where we are connected to. So we created that free cluster, and then as environment variables, we provided the MongoDB connection string. And so in this cluster, this is launching pad. You can see that I have this free cluster here, and there are certain buttons. There is metrics, there are collections, they connect, and I'll quickly show the connect. So if you want to connect your application right now, I'm IP whitelisting, so anybody can connect to, but still we are using username and password. It quickly, you can go and see, okay, if I want to connect through a shell or I want to connect my application, let me show you the application quickly. So you can choose to use SRV connection. So you choose connection string, and it shows you right there what is your connection string and hides out the password, and you just copy it, take it back to your application, replace the password with your password, and voila, you have the connection string. How many times you have to find out the connection strings for applications? So this does it really well. You can go down and go to Java, Python, Ruby, or Node, and then get the example of how we use MongoDB connections. So on this cluster, it shows you high-level matrix of how many read operations. We just saw that one write happened. You added a new collection, and we read all the lists, so you can see when the read and writes are happening. You can click on the matrix and go see a lot of metrics about how many connections are open, what are the operations going on. There are some hardware metrics which you can see as well, so you can add a lot of metrics. So in the free cluster, there are less number of metrics available, but when you go for a production level cluster like M30 and above, you get 100 plus metrics there, and I can quickly show that. So I'll go here and click on the collections, and we just released that. So the Data Explorer 4.0, now it is available on Atlas. So you can go here right there. That was the to-dos cluster project we created, and in that we have the to-dos collection. And here from the UI itself, we can see that all the tasks we created. And if I scroll down, I can see that the Cloud OnAir task we created, and then we can see when it was created and whether it's completed or not. So this quickly lets you, from the UI itself, I showed Compass, which is MongoDB's UI, to basically a tool to connect, and you can do much more. But if you really quickly want to troubleshoot and see how my data is coming in, and create a quick filter, like you can do queries here, you can do it right from the Atlas UI, which is pretty cool.
Yeah. Show the resources, please.
Yeah. Yeah. And so we did all that, and now coming on to the resources. So the GitHub repository is there. Clone it, play with the code. The GCP free tier from MongoDB Atlas, you can go to this link and see how to get to MongoDB Atlas. You can always go to cloud.mongodb.com and create an account, and without a credit card, create a free cluster. You want to talk about the GCP?
Yeah, so we have on the top, as well as the GCP free tier for Mongo Atlas, you can also leverage the GCP free credit with $300 that can be used for any product at GCP. So you can go to cloud.google.com/free to use that.
Cool. And then there are two links to the original MERN stack blog, and then updated blog with MERN and MERN stack.
Yeah, great. All right, thanks everyone for listening to our webinar. So stay tuned for live Q&A. We'll be back in less than a minute. All right, so we got a lot of questions from the audience. So first question is, can MongoDB free tier be upgraded to large clusters?
Absolutely. So MongoDB free tier is a great way for you to quickly get in without using a credit card, create a free cluster, and play with it. When you are ready to move your application to more serious node, then you can easily go in to Atlas UI, say edit cluster, and then choose the cluster which fits your read-write patterns and size.
Nice. That's great. So how to choose the right cluster tier for Atlas?
Yeah, and that's a very good question. There are many cluster tiles available. We talked about the free cluster, that there are development clusters, there are production clusters, and they all come with a certain amount of RAM you want to use, what is your data size requirements, how much data you want to store. When we choose the right cluster tier, like we try to get how much, basically, what are your read-write patterns, how many reads you're going to do, how many writes you're going to do, what is the data size, and also we want to look at how my data will grow over the time. Today I might need 10 gigabytes of storage, and tomorrow it goes to a terabyte or petabytes of storage. So you can choose based on those characteristics what is the right cluster tier. But the great part with Atlas is it's elastic. So you can start with a cluster tier. Like say example, you want 10 gigs of RAM, 10 gigs of RAM today, and then 10 gigabytes of storage, and you can start today at a lower cluster and easily scale it up, add more memory. Atlas also it has a auto scaling setting for adding more memory.
I see.
So if you're running out of storage, Atlas will automatically provision more storage for you.
Yeah,
so
that's great.
There are many ways of doing it, and if you're building a large enterprise application or you're building something you want to talk to MongoDB solution architects can help you size your application and how it should look like.
I see. So next question is, why should I use MongoDB Atlas on GCP?
It's a great question. MongoDB Atlas is cloud agnostic. We work with 3 of the major cloud providers today, GCP, Azure, and AWS. Every cloud provider has their own strengths, and you can choose what strengths you want to use. Maybe there are certain reasons you want to go to, so it's really good idea to choose GCP for the reasons GCP is supporting. Google is really a pioneer in machine learning. The machine learning and AI services on GCP are really good, and if you want to utilize those, you can come and use that. And the tip I will give you is GCP gives really good DIX IOPS when you are building the cluster on MongoDB.
Yep.
So Atlas, so those will be some reasons I'll go to GCP.
Yeah. That's great. So the next question is, what is the difference between Kubernetes and GKE? I think I can take this question.
Sure.
Yeah, so GKE is a Google Kubernetes engine, so it is fully managed service for Kubernetes. So we heard from a lot of users of Kubernetes that it's actually very cumbersome to manage and deploy the Kubernetes on their own. There's one blog that actually shows us running the Kubernetes on your own, and which really goes beyond 6 pages of notes, which is a lot of work for the engineers to deal with. So GKEs actually really provide fully end-to-end management services, whether it is monitoring or security or deploying it, adding the services like you've seen in the demo app. So we take care of all this deployment aspect, mundane administrative aspect of the Kubernetes, so that you can really focus on building a great app.
Right, and just to add to it, like same way, MongoDB Atlas, you can do on-prem MongoDB, but Atlas automates, takes away all the work from you in building your infrastructure, procuring infrastructure, ensuring security, ensuring best practices. So together with GKE and MongoDB Atlas, you can get your application to production in no time.
Yes.
Yeah.
All right, so that's all for today. So please tune in next Tuesday for next Cloud on Air. Thank you for watching.